Okay, I have cut out the plane now, and we have of course, the original drawing that I made kind of here for the form, and so I'm trying to stay as true to this form as possible here. So I'm just going to kind of like show this as high as I can. Maybe you can kind of get a look there. And this has all been critically measured. So show it from a different angle here. So I have measured every possible position here using my 1 inch on this square here. Each square on this drawing equals 1 inch. So I feel like that this is a really good representation here of the plan as I've cut it out. Now, nothing's glued in yet. I've just kind of laying this stuff on top right now just to get a feel of what it looks like and to see if there's any issues. Now, you notice I've got an EDF and a couple of batteries there. So I'm going to end up using two 2200s in parallel because this motor system draws about 60 amperes full throttle, and it's beginning to tax these batteries. Even though they are graphene batteries, they do begin to heat slightly. Then when I put the two of them in parallel, it completely removes that problem. So I've already done a bench test using this motor and these batteries, like in that configuration. Now let me go over here. I want to show how I determined a couple of things, and I've went over this several times now. But so we have the wing here as a paper doll, and what I did is I took that wing over here, and as you can see, I've simply put this on this page. Okay, and then I've done the MAC procedure, mean aerobatic center, which is the center of lift on this surface. And since it's a delta wing, the center of lift is not going to be right in the center of a box, which would be up here. The delta wing makes it move back this way. Just you can see that by visually looking. But what I've got here is I'm showing where the CG is on this airplane, right there. And I've done the calculations where we take each end and put them here, like so, to get these 4 lines, actually 2 lines intersecting at the MAC. And then I perform this equation here with 14 inches from the MAC line, is what we call this. 14 inches, if we take 25% of that from the leading edge, it comes back to this point right where my finger is. We draw that over, and that's our CG. I've went over this in other videos. So it ends up being 3.5 inches from the leading edge, or 9 inches from the leading point of the delta here. So that's our CG. So what I wanted to say is I've done this, as you can kind of see here. If we look at that in the wing here, this point right here is a line that I have drawn right there. If you can kind of see that. See, it's 9 inches back from the wing, which is this, and the CG is right there. Now, where do we put the objects that are going to have mass, which is the EDF, the batteries, some servos, some wires, ESC, etc.? Well, what we do is we measure. We use a measurement here. We say that if this is the CG, and this is the forward of the plane, and this is the aft of the plane, well, if we know that the battery has a weight, and I have weighed this battery with this scale, let me show that. This is meant to be a procedure. If you had not known how to do this, I'm going to measure the weight of these batteries. So we show that it's 1 pound, 1 1/4 ounces. So that's where this number comes from. 17.25 ounces is indeed 1 pound, 1 1/4 ounces. Now this is the battery that we're talking about, or actually both batteries together. Okay. Now we're going to weigh this device, which is our EDF and motor, It says it weighs 6.5 ounces. So now we have 6.5 ounces here, which is the EDF. So if we perform this equation, we take the weight of the heaviest item, 17.25, and divide it into the weight of the lightest item, 6.5, so we have the fraction, and we multiply it by the dimension B, we will get the dimension A. So what we're saying is we're going to assign a dimension to B. So that requires looking at the plane, deciding to put this about in this area. It's going to go on top of the plane like this. There will be no holes cut in the plane. So that looks about right to me. We don't want it too far back. We want this to be able to have a nice vertical upright, which is going to start about right here. So the vertical upright will come out like this, you see. And there has to be some meat in front of the vertical upright. So that's why I'm choosing this location. It's fairly arbitrary. So that dimension from the CG to the center of the mass of this is our B dimension. So we can kind of look at it like this. We have our B dimension, CG, CG, B dimension, B dimension, and we have just calculated that we needed to have 2.63 inches for A. A is the dimension from the battery back to the CG. So I'm kind of going through this quickly, but if we put the batteries here and we measure a distance using a scale here, and we see that the scale here is in inches and in tenths of inches, we're going to go about 2.63 inches forward from the CG. So roughly something like that. And that should be the center of the batteries, the center. So I've got it about right. Now if we have to adjust it, we can always slide the batteries slightly forward. This will give us a balance point by this equation, and these dimensions will give us a balance point right there on the CG, which correlates to our original drawing that I showed, which I'll show again here. It correlates to this drawing right here. And our CG right here, which we pointed out is right here, which is 9 inches from the center, 9 inches from the tip at the center of this tip back to here. So this should balance our plane. Now, there's really not much more to say here right now. I have decided that I'm going to have a single elevator, no elevon control. Single elevator, so this is our elevator right here, and it's going to be tied together as one unit with one hinge clear across, straight across this device like this. We're not going to have a cut in this, in other words. Originally I'd shown a cut here where we're going to have two halves, but I decided to go with one elevator half and two servos working in tandem here to create force on each side, but have a nice tied together system. Now the tail will have to change slightly from my original drawing here. So to show that, what will have to happen here approximately, just kind of pencil it in here to show you, this will have to be cut up something like this, if you see what I'm saying. And the reason for that is because we will need a space for this elevator to come up and not hit the rudder, if you see that what I'm trying to show there. And that will of course be cut. The rudder will be right here, and it will be cut up. So it will be cut up like this at an angle. So we have room, in other words, we have room for this elevator to come up and without hitting the rudder. So this kind of shows what I'm saying, like this. You see, so it's gonna have a cut like that on the rudder, so that when we raise this up and down, we'll be able to do so without hitting it. So let me kind of try to show that. So what I'm saying is it will be like that, you see. So we'll have a cutout here like this. See, right up like that is what I'm saying. And that represents this little area here that I'm showing right here. So that's about it. Pretty pleased with my progress. The front system is yet to be cut. I've got to cut a piece right here to make it scale, and then this is going to come up. We'll have a profile fuse that will go set right in the center here and pass right straight back all the way through the tail of this system. And then we're going to have a carbon fiber rod going from the front to the rear. I ordered some 48-inch carbon fiber rods, and we'll have another carbon fiber rod that will go right across this plane. Get all this stuff off here. We'll have a second carbon fiber that will go right on the CG, right across from tip to tip of the wing and be glued. And then we'll have a third carbon fiber that'll be right here, just behind the motor. So here's our motor, and the rod in the rear will be situated in the back end, on the very back end, like this, approximately right here. And it will come down like this on each side. And then on the edges here, we're going to have a aileron cutout, approximately 1.5 inches to 2 inches here. The aileron will come to about halfway over like that, which I have not cut out yet. So that's the plan. And in the next video, I should be showing some glued up pieces for us to take a look and see how to build up this system. I'm going to have a couple of pod ledges here, pieces that are glued here that this can tie into to hold this up off of the plane. So that's one thing I've not designed yet. Okay, more to come.